Hi, and welcome back to another lesson. In today's lesson, we are going to discuss inelastic collisions, and then we are going to work out two examples related to inelastic collisions. So, let's look at what is an inelastic collision. In an inelastic collision, we have two bodies colliding with each other, but after collision, the two bodies stick together and move as one. As a result, we treat them as one single body. Here are another two examples of an inelastic collision. In both cases, we see two bodies that start as a separate body, but after collision, they move together as one body. Just like there is a mathematical model for an elastic collision, which was discussed in the previous video, and you can find a link to that video in the description below, there is also a mathematical model for an inelastic collision. Similarly to an elastic collision, ideally, we start by splitting the question into the before and after. Before collision, you will normally have two bodies. Each body will have its respective mass and velocity. After collision, the two bodies stick together and move together as one body. As a result, they will have a combined mass and a common velocity. We then write the conservation of momentum. This was also described in more detail in the previous video. Afterwards, you ask yourself the question, how many bodies do I have before collision? In this case, two bodies. So you write a bracket with the momentum equation for each body, and you add them up, since it is the total momentum. Then you ask yourself the same question, but now with respect to after collision. In this case, after collision, you treat the two bodies stuck together as one body, and therefore you write one bracket with the momentum equation inside. Remember that the mass is the combined mass and the velocity is the common velocity of both bodies. Over here, we are seeing the same approach, however the model is modified a little bit to cater for the fact that one body is moving in the opposite direction to the other. As a result, the velocity of body B before collision has a negative sign. After collision, the common velocity can either be a positive or a negative, depending on the direction in which both bodies move together. To the right, we assign a positive, and to the left, we assign a negative velocity. Let's work out two examples to make sure that you are understanding how to work out problems related to inelastic collisions. Okay, so let's look at example number 1. A bullet of mass 0.025 kilograms was fired at a speed of 50 meters per second when it collided with a stationary wooden block of mass 50 kilograms. The bullet sticks to the block and they move off together with the same speed. Find the speed with which the bullet and the block continue moving together. So, as we discussed earlier on in this video, ideally we start by splitting the question into the before and after. Before we have two bodies, so I'm going to represent those two bodies by drawing a rectangle for each body. This will be body A. Similarly, we have body B. Each body has its respective mass and velocity. The mass for body A before collision was 0.025 kilograms, while the velocity for body A before collision was 50 meters per second. The mass of body B before collision was 50 kilograms, while its velocity before collision is 0, because in the question it is clearly stated that the bullet collided with a stationary wooden block, and therefore that means that the wooden block before collision has a velocity of 0 meters per second. Now, after collision, we can see that the bullet sticks with the block and they move off together with the same speed. That indicates that you have a case of an inelastic collision, and therefore after collision you're going to have the two bodies combined as one. And therefore, to represent that, we are going to draw one combined body, A and B. Body AB, or the combined two bodies, now have their respective mass. And the mass of both bodies combined together is equal to 50.025 kilograms, while the velocity with which the two bodies continue moving off together with, we need to find that one. We start by writing the conservation of momentum. So the total momentum before is equal to the total momentum after. Now, by looking at the above diagram, we can see that before collision we have two bodies, and therefore we're going to write two brackets with the momentum equation inside, one for body A and one for body B. After collision, even though we have two bodies, since these two bodies are now combined, and because they stick together and move off as one body, we have to draw only one bracket. And this bracket will be common for A and B, will be common for both bodies. The next step would be to replace the quantity with its respective value. So the mass of body A before collision is 0.025 and the velocity is 50. The mass of body B before collision is 50 kilograms and its velocity is 0. After collision, the combined mass is 50.025 times v, because we need to find the velocity with which both bodies continue moving together. We work out each separate bracket and we get 0.025 times 50 equals to 1.25. 50 times 0 is equal to 0 because anything times 0 is 0, and 50.025 times v on the right hand side of the equation. Therefore, 1.25 is equal to 50.025 v. To make v subject of the formula, we want to make this v subject of the formula. We take the 50.025 on the other side and we get 1.25 division by 50.025 equals v. You work that one out and you should get an answer of 0.025 meters per second. For the second example, we have a boy of mass 50 kilograms running at 5 meters per second collides with another boy of mass 45 kilograms that was running in the opposite direction at 2.5 meters per second. Find the final velocity of both boys after collision and state in which direction they moved. So, similarly to example number 1, we start by splitting the situation, the example, into the before and after. Before collision, we also have two bodies, so we're going to draw two rectangles to represent body A and body B. Each body has its respective mass and velocity. In this case, body A has a mass of 50 kilograms and was running with a velocity of 5 meters per second. Body B, before collision, has a mass of 45 kilograms, but was moving with a velocity of negative 2.5. Remember, negative 2.5 because body B was actually moving in the opposite direction as body A. After collision, the two boys, they collide with each other and they continue to move as one single body. So we are going to draw body A and body B combined together, and body A and body B combined together, they also have a combined mass, which in this case it's equal to 95 kilograms, and a combined velocity, which in this case we need to find. Again, we start with the conservation of momentum. Before collision, we have two bodies, so we're going to draw two brackets, and in each bracket we're going to write the momentum equation. 1 for body A plus 1 for body B. After collision, even though we have two bodies, but since these two bodies, they are combined, they stick together and they move off as one single body, we are going to draw only one bracket. The next step would be to replace the quantity with its respective value. So the mass of body A before collision was 50 kilograms and its velocity was 5 meters per second. The mass of body B before collision was 45 and the velocity was negative 2.5. The combined mass after collision is equal to 95 and the velocity we need to find. You work the value of each single bracket, so 50 times 5 is 250 plus 45 times 2.5 times negative 2.5 is negative 112.5 is equal to 95 times V. You know that a positive and a negative yield a negative, so that's going to be 250 minus 112.5 equals 95 times V. 250 minus 112.5 is equal to 137.5 equals 95 V. We want to find the final velocity with which both bodies continue to move together, and therefore we have to leave V subject of the formula. So the next step would be to take the 95 on the other side, and from times it becomes division. So 137.5 division by 95 is equal to V. You work that one out and you should get an answer of 1.45 meters per second. Now, to identify in which direction both bodies continued to move together, you have to look at the value of the velocity. In this case, we obtained a positive value, and therefore we know that both bodies continued to move in the right Direction? If the answer was a negative value, that means that both bodies continue to move in the left direction. Thank you for watching this week's lesson where we discussed inelastic collisions. Stay tuned for the upcoming lessons where we are going to discuss explosions. Till then, stay safe.